will be having huge volume of data. So generally it will be spanning up to GBs and TBs. So that GB space, if it is available in your Google, so you will be able to access it. So suppose if you want to go for Azure, there also you'll be able to get that particular link. Okay. So here the first part, I'm just going to import this particular module. Now my system will be connecting. This is a browser-based system. Okay. Many people will be knowing it, and you will be also using it. So here the system will be getting connected with the devices. So here in the top, you can see, you can also run the same program because I shared the actual module to every one of you. So it will be connecting, and the virtual space will be allocated to us. Once the virtual space will be allocated to me, the process will be getting executed. Okay. And you'll be able to connect all the applications through your browser itself. You don't need to install any of the applications here. Subsequently, I'm just going to check what are the subsequent operations that we will be having. So I'm going for the next module where you can access your, there is Google Drive. So Google Drive, I'm just mounting it. So once I want to mount my Google Drive, so I need to access one particular application package, which is called Google Colab. So which will be mounting my drive, and it will be available here. Here you can initially see, okay, what are the files that are available. Here you'll be having only sample data which is available and which is allocated for me in the virtual machine. So once I run this particular application here, okay, once I run this particular code, it will be mounting my Google Drive. Okay, so here it will be asking for connect to Google Drive. Then I will be connecting my personal Google Drive where I have all the data with me. Is it visible? Is it visible? Then I'll be giving permission. Once I give the permission, it will be automatically mounting my Google Drive. You can see towards my left side, okay, my Google Drive will be mounted. Okay, it will be taking some time because the volume of data that is available, it will be more. So after that, I'll just refresh this. If I refresh this, you can just see my drive got connected here. Then you can access whatever the contents that are available in Google Drive here. So this is what that will be happening. So once this has been completed, I can access everything. Then I'm going for the subsequent operation. Initially, I'm mounting one particular image, whatever that I have in my Google Drive, into this particular into this particular vision. So that particular process I'm doing it. So there is a simple command that we will be having it. How you can access this particular thing using that is OpenCV. Open Computer Vision is the basic application package which you will be having. So using that, you will be able to access this particular content into your into this particular viewport. So I'll just go to the actual execution. So I'll just get this particular import CV, which will be getting my packages. There is Computer Vision 2 packages. Everything will be getting here. Then we are going for the loading image. Okay. So here you can just see, I have read. See, I've already got my Google Drive, which has been loaded here. So Google Drive will be having your images. So that particular image that I'm going to load. And there is one particular issue with this particular browser-based execution, that is Colab. You will not be able to show the image as it is. So we will be going for matplotlib files, so which we would have used for many analysis for plotting the plot. So during that time, we will be using that plot. So the plotlib libraries we will be using here for displaying the images. So that's what I'm going to do it. So here, once you go forward, you'll be able to run this particular file, and you can see my image, whatever that is available in my Google Drive. It is pretty old image, so that will be displayed here. Post this, you can just see this will be giving in the form of plots. Okay, now I need to remove this particular thing. So it is very simple process. These are all fundamentals which are required, okay, for doing any image processing. And we are directly going, see, nowadays we are not going to use this. We will be just giving that particular image. Post this, what it will do, the model which we are using, which has been already created, that particular model we are be using to get the particular contents. So here we will be having this. Then later, after this, we want to show it as an image. So what we will be doing here, we will be just taking the particular image, particular part, so that we will be removing this. See here, you can just see the plot ticks that I am going to remove it. So you'll be getting that particular, there is the plot effect, whatever that you have it, that will be removed. After this, what we'll be doing, the basic image processing operation, okay, the size removal, changing to, there is a grayscale, all these things we will be able to do that. So this is the fundamentals of image processing. Now we are at advanced level. That is what we have, the convolution neural network, okay, for the object detection, object identification, and the some more processing, that is slicing, Okay, all these things we will be able to do it in the subsequent process. So that particular process, when we are going for this, you require this particular image, only the input particular part it is required. So this is one particular filter where the image is converted into grayscale. So this particular thing that we will be using. So these are all very fundamental and primitives of image processing. And this is one particular original image where you will be having the particular thing. Then we can do the flipping operation of this particular images that we can have. Horizontal flip, vertical flip. These all are based on a basic equation that we will be doing with respect to matrix. Then we have certain things that we will be requiring for our basic operations of this, the size of that particular images that we will be extracting, so that we will be having that RGB component. So we will be giving the particular pixel level. So here you can just see the image 100,100 that we have taken, and that particular thing will be converted, and you will be reading that particular image values. That is what is stored in RGB component that is required for us to do processing. Okay, whatever might be the processing. For example, when the model is being built, it is trying to get the tumor from the given images. So how it is going to take it? So what is the pixel value that is required, and how it is going to verify with the subsequent pixel, and how it is going to take that particular image from the particular slots? All those things we will be having. So initially we will be going for the segmentation that I will be showing you a sample, how the segmentation process is happening. So all these things it will be happening, and whatever that we do, we need to save the particular image in that particular Google Drive. So in that particular process, what we will be doing, we require, see, the single image has been taken. After doing slicing operation, okay, we will be having multiple smaller images where we will be feeding it to each and everything one particular there is the particular node. So that particular node will be doing parallelly this processing. So once the parallel processing is start, it will be extracting the information or the interesting patterns from that particular image, and it will be giving it. That interesting pattern, it will be helpful for us to do the analysis part. So this is how the whole process will be happening. So how to save that segmented image? So that particular part has been given here. So that particular part has been given here. So the image.iWrite is the particular function where you can store the segmented image. That particular part will be here. So then subsequently, we are going for the complete image write method, which will be writing with the new name, so that can be updated. So you will be having array of the segmented images of one particular image where we will be doing this analysis part. And if you want to remove some of the redundant, for example, if you have two segments or two patterns which is giving the same values, so those things we need to remove. For that, we will be using the remove function, which we are using in parallel, and most of this particular part we will be automating. We will be running in a loop, and we will be doing this particular processing. So this is what we will be happening. Now we are going for our interesting session. See, after this, we have gone for the machine learning model. In machine learning model, the subset we got deep learning. In that, there's one particular model which we exclusively use for image processing as mainly the object detection is your there is convolution neural network. And one more method that we have used for there is for prediction, okay, with sequential data. There is, for example, if you're having continuously a sequential data, so how that can be predicted and all that particular, you will be using RNN. So this transformers, whatever that we are discussing, initially it had taken components for RNN. It will do the same functionalities as that of RNN is doing. Okay? So in that particular process, what it will be happening, you have in natural language processing. I'll just go to that particular place where you will be having better visibility. These are all some operations that you have. So this is again two images that they are there. The people are animating from one particular image to another particular image. For that I've shown, okay, two images that I have taken, and the third image we have been built using these two images as input. So that particular process it is happening here. So you can just see the same two images that we have taken, and the third one, the built image, that is mixing these two images. What was the results that you will be getting? So this is the resulting image that you are getting. So all these things, it will be happening with respect to the same RGB component which we have discussed earlier. So that particular part, okay, how the RGB component is extracting and how it is substituted in the equation, how it is calculation, that we are not discussing here. Instead, we are discussing how the API functions are the functions it has been used to complete the process. Some people, you want to design the API. For them, you need to know the concepts, how it has been happening. For people who are going to do the research, they will be requiring this particular internal components. For those people who want to do the application and they want to get the insight, for example, the telemedicine, there is one particular device that they got. In that particular device, it is giving more number of data to us. So that particular data is being collected. So you want to do the analysis. So once you are in that particular analysis stage, you will be supporting the business in giving that input. So this is how you can improve your sales, or this is how you can improve your device. So that particular type of analysis only we are seeing here, not how to design an API, okay, for the particular engine. So that particular process we are not discussing. So now we are going for the transformers and neural network. So basic architecture I'll be just giving. The transformer in general, yes, it is also one of the deep learning model. I won't say similar to machine learning. Okay, deep learning is a subset of your machine learning. Here, deep learn in this particular transformers is also one model of your deep learning. So it has the mechanism of self-attention. Okay, and what is meant by the self-attention? All those things we'll be discussing. And second thing, it will be taking this particular input data and it will be fed to the decoder. Post that there will be a processing, and that encoder will be, initially it will be encoder, then there will be a processing, and after that processing set, you will be having the decoder, which will be giving all the segmented values. So I'll be just giving you a simple architecture for this. So here you have the initial input, it has been given, and output encoding, that will be parallel, that you leave it afterwards, then we will be having it. See, in your recursive neural network, recurrent neural network, or RNN, what will be happening? If there is a statement, okay, that statement will be processed one by one in a sequential manner, where I have one particular example for that. I'll be showing that example. Okay, I think I missed that. Okay, no issues. I'll share that. See, suppose if you are having a statement in NLP, once you are doing the processing, how it will be doing the processing? So it will take each and every keyword. Okay, after processing that particular keyword, it will be going for the subsequent keyword. After that, it will be going for the subsequent keyword. So the sequence will be happening in that way. So suppose if you are having 4 keywords in a statement, in RNN, each and every keyword will be processed one by one. But in the case of our transformers, all the keywords will be taken in individual slice. Okay, that will be head to multi-head attention. That is means each and every word will be processed in a parallel. Okay, and it will be sent to, we generally call it as black box, or it will be sent to the node. Okay, there it will be sent and it will be doing the processing, and subsequently it will be given to the next level and it will be going for the next level. The weight will be adjusted based on it. So by knowing the particular data, it will be automatically adjusting the weight of that particular process. And then finally it will be going for the feed forward network, and then it will be going for the there is decoding option. Initially it is encoded, should be decoded. So then it will be given the particular value. Just I'll be just giving you one particular one more example which I have here. I'll just navigate to that particular page. So only 1 minute. Because that gives a visual representation of this. Okay. This is one particular tutorial which people who are starting your vision transformers in the beginning, so they can refer this particular tutorial, which is also shared in my material. So here you can just see, I'll just go to the example part. So this is the initial image. Okay, so this initial image, it will be available in this particular form. And when you go into the particular vision transformer, how the image is segmented into multiple pieces, that will be shown here. So here you can just see, initially you are feeding. Okay, so in general they will be calling by 16 by 16 splices, like that they will be saying. Here the particular model is taken 14 by 14 slices. So each and every slice will be given, and it will be going to the transformer encoders. Okay, so the transformer encoders will be extracting the pattern of each and every particular slice, whatever that is available, and that will be available in this particular mode. So that we call it as vision patches, visualization patches. So then we will be having that particular subsequent model. Then when we compare that particular model, and we will be getting the similarities, and those similarities will be represented in this particular form. So this is how we will be getting this particular thing in the vision transformers. Then we will be using for the analysis. So once you get this particular processing part, you will be converting that particular processing part into required output. So that will be having one particular model. Based on the expected model, you will be getting this. Now, all these particular process what are putting together, they are given n number of encoders. There is n encoders which will be taking that particular input based on the row. There is a n by m values that you are giving. Generally, it will be of square type, a square matrix type. So you will be giving n by n. So once it is dividing, then the pattern matching will be much easier. Otherwise, if you are not giving this, then you need to scale down that particular thing once you are doing for the pattern matching process. So this is how the whole process will be happening. So once you get this, enter into this particular vision transformers, you can run the particular model, and there are n number of identification and other processes. So they have there are some dependencies. Once you are using this vision transformers, there are some dependencies packages that are available. Once you have transformers, then you need to include TIM packages. So once you are installed TIM packages, you need to see the version compatibility between the multiple transformer modules and this particular module. And you need to transformers. In transformers, you have pipeline. Post that, you will be having TIM. Once you have these modules, you can execute this APIs. So you can get that particular predefined modules from the pipeline itself. Then you can execute and get the particular output based on the input that you are given. For example, I have given particular one image input. So that image is having beach with sun and clouds and some trees also that is available. So once you feed in that, that is the first program in your vision transformers that it clearly says identify the objects and draw the square around that particular objects. So this will be happening. So once you run this particular program, I have fed my beach image. So it will be showing what are all the objects. You can just see there are squares around sun, there are squares around the tree, and you can see the sea. Okay, it is completely made in one particular square. So once you do this particular processing, you will be getting this particular patterns. So this particular patterns, you can use it for further analysis. So this is basic object identification program which we have run. Okay, and see, once you go into this, as of now, when it comes to the open AI, okay, you can see there is text-based generative models that are available. GPT is available. Now the image-based analysis, that is pre-trained transformers, okay, generative pre-trained transformers that are available with respect to your text, what you call it as chat GPT. It is a chatbot, AI-based chatbot. So similarly, okay, the vision transformers is going to reach one particular level where you are going to have your there is image-based direction, there is image-based object identification. If you submit image, all those things, it will be able to get it. So I think someone have raised the hands. Any queries is there? Someone have raised the hand.
Doctor, you can continue, doctor. We will have that query and question after your session.
Okay, okay, no issues, no issues. See, whatever that we are discussing here is very fundamentals. Okay. In fact, there is a one particular session probably we can have separately for this particular process. So once you give any object, okay, as I shown here, we have taken. Okay, I have some issues. Okay. So now this is the input image that we have shown. So that particular image, it is giving the object. So that particular code I am just showing you. Very simple code. So here I just shown the installation. You need to install. Suppose if you are using any Python compiler, you need to use pip installer or conda installer. So you need to install this transformer for you to execute it. So once this has been installed, you'll be getting this particular input. Then after that, you need to install TIM. That is the dependency package for your transformers. This is a TIM package. So it has also you need to install. So I have installed 0.6.12, okay, for my execution. Then the final program, okay. So the final program here, you can just see you got the transformer, and I have taken the beach file, okay. Then it will be executing it. So once you want to execute this particular thing, please make sure that you are executing the image. It is available in your local data. Then only it will be executing as per the expectation. Otherwise, it will not be executing. So that's why you've shown once you are executing from this particular file itself, what is the error which will be generating. So you need to move it to your system. From there, if you execute, so that image that I have shown now, so that output you will be able to get there. So this is what that we are having here. So any clarification related to this particular process, if you have, you can ask here, so that we can conclude the session by giving the input. See, let me give you very simple in a nutshell. Okay, vision transformer is one particular newer version of image identification, whether it could be sequential image or a standalone image. If you are giving as an input, you can do analytics as you are doing in convolution neural network. And this transformers is derived from RNN model, but it will be having multiple nodes which will be doing the parallel processing. So within the short duration, say the main advantage of your vision transformer is the training can be done at fast phase. That is the main advantage of it. Otherwise, when we submit our training model, so it will take at least 24 hours. Sometimes it will take 120 hours to get it trained. That especially when you are giving the MRI scans and other things. So now it will reduce the time drastically. Training model can be built at fast phase. Yeah, there is the size irrespective of the size. As of now, this is the advanced model that we have, which will reduce the testing time. Sorry, training time. It's extremely sorry, training time. So any clarification from your side, you can ask. The platform is open for you.
Doctor, I think
Yes, sir. Yes, sir.
you have finished your presentation, or
yes, sir. Yes, sir. I have finished my presentation.
Okay. Thank you very much, Dr. Nageshwara Gupta. Thank you very much. Despite your busy schedule on the travel, we have seen more virtual seminars and conferences where the participants are attending the conference in the car or with the travel. But first time we are happy to see you presented a mobile presentation. And thank you very much for your time and dedication that you had towards us. Damidolo University is proud to have you today in this platform, and we really appreciate the topic as well as the way you presented. It was very informative for all the participants. The information, the recording will be shared to you. Okay. Next, we have, if there is any questions, the participants can raise their hands and we can unmute them so that you can ask some questions to Dr. Nageshwara. Is there anybody who needs, who's ready to ask a question?
There were two people who have raised their hands.
Who are, just a minute, Doctor. We'll unmute them now.
Okay. So everything is good. All good, all well. So in case if anyone is planning to do your research in vision transformer, you can connect through Professor Sampath to me. So we will be able to do it.
Once again, thank you, Dr. Nageshwara. It's over to Dr. Sampath.
Thank you, sir. Thank you, sir.
Dr. Sampath has to share a few words with Dr. Sampath.
Can you hear me? Yeah. Thank you, sir. Thank you very much for your session. Because we are facing some internet issue, that's why we can't able to proceed it smoothly. Sorry for that. So that it's a wonderful session that how that image transformation taken place in the artificial intelligence. So previous session we have seen about the telemedicine, so that our Dr. Nageswara Gupta sir have wonderfully connected the previous session with the current session. So my heartfelt thanks, sir. My heartfelt thanks for you for giving me this wonderful time, even the busy schedule you have. Thank you, sir. Thank you. Thank you for the session.
Hello. Am I audible to everyone? Am I audible? Hello? Am I audible? Can you hear me? Yeah. Dr. Lincoln, am I audible? Please raise your hands. Yeah, thank you, sir. Thank you very much. Thank you very much. So let us move on to the third session. And I was just wanted to give a small reminder that this seminar, an international seminar on the impact of artificial intelligence, is happening from the Department of External Relations Coordinating Office of Debidolo University. I would like to extend once again the thanks to the Director of External Relations Coordinating Office, Dr. Dhruba Andashar. Thank you very much. Let us move on to the third session. I would like to invite Dr. Amudavel Jayvel, a senior researcher at the University of Tartu, Estonia, and his current research interest includes computer vision, deep learning, and quantum machine learning. We welcome you, Dr. Amudavel. Thank you very much for coming and accepting our invitation. We would like to just move the session to Dr. Amudavel. Over to you, Dr. Amudavel Jayvel.
Thank you. Shall I share the screen, sir?
Yes, please go ahead. Please go ahead and share the screen.
Yeah. So, is it visible for you?
Yeah, it's visible. It's visible.
Yeah. Yeah. Very good morning to one and all. So here we are going to discuss about, first of all, I would like to thank the Debidolo management for inviting me to this seminar and to the invited talk. So today we are going to see, and today we are going to discuss about the various types of innovations in deep learning. I think in the previous session, Dr. Nageshwara Gupta briefly explained about vision transformers and these related things in detail. And we are going to see now the different aspects and different innovations which is lately happening in the deep learning now. And you already know deep learning is a subset of machine learning, and it has seen a tremendous progress in the recent years, right? the ability to train the deep learning networks with the large amounts of data has led to a breakthroughs in the wide range of applications, including image and speech recognition, natural language processing, and even the game playing also. Right. One of the major innovations in deep learning is the development of convolutional neural networks. Right. So you already know the architecture of the convolutional neural networks, which is a very basic terminology which we can discuss when we are dealing with the deep neural networks. Right. So here, the CNN use a process called convolution to extract features from images, which are then passed through multiple layers to classify and identify the image. Right. So this is the very fundamental of the deep neural networks and related things. But here we are going to see and we are going to discuss a few things about that. Right. So these are some of the goals we are going to do right today. First of all, we are going to understand what are the latest innovations deep learning has happened today. And secondly, we are going to understand the difference between what exactly you mean by generative adversarial networks. And after that, we are going to see about the difference between generative and discriminative models. And after that, we are going to understand the roles of generator and discriminator in the generative adversarial system. And after that, we are going to discuss about and we are going to understand the loss functions which is happening in the generative adversarial training. And after that, if time permits and if the architecture permits, then we can just have a look around what exactly you mean by TFScan, it's a TensorFlow library. And if it is not possible, then I'll shoot out the links for you so that you can try it on your own. So this is the basic agenda of this session, right? So I just want to make sure that this session will be an informative session and as well as interactive session as well as an interesting session, right? So before that, it is not like a very detailed thing because you already have all the kinds of notes and everything in the internet, right? So I just want to make sure that the concept you are trying to understand or else the concept you are trying to conceive should be more clear, right? So with that, let's move to the next one. So here, you can able to see the celebrities, right? Yeah, just a second. I'll connect my charger here. Just a second.
Sorry for that. I think there is some technical issue with Dr. We hope that he'll join us very soon. Let me try to contact him once again. Please stay on. Just stay on. Then we are trying to contact. There is a technical issue. Apologies for the inconvenience. We hope that Dr. Sampathkumar will join us very soon. Please stay on time. He's on going to be online very soon. Sorry.
Uh,
Thank you, Dr. Sampathkumar, for joining us. I hope there is no
yeah,
technical
and I would like to kindly accept my apologies for the thing happened because
Okay, so
I
go ahead.
it's running out of storage. Thank you.
Okay. Thank you. So you can go ahead. Thank you.
So, continuing with the previous session, can you? So this shows four celebrities, right? So, can you able to identify those four celebrities from your end, right? So these are the very famous celebrities. Maybe you can name any one of them. So, can you be able to identify these celebrities because these are all the very famous celebrities? But the real thing is that these
What famous?
celebrities. Hello, am I audible?
Yeah, you're audible. You're
Yeah.
audible. I hope that
So these celebrities are generated by the generational adversarial networks, right? So these are the images which is generated by the generational adversarial networks, which looks like very plausible, right? So this is the power of deep learning now. So I hope you already heard about deep fakes, right? So some of them will recreate or else so anyone can transform to anybody. That is the power of deep neural networks there. So this is the best example. And the next one, you can see how how this photo is getting generated, how it is plausible to nature, how it is very realistic in nature in this way only. You can see these are all the core styles, middle styles. It is listed out there, right? So core styles, middle styles, and fine styles, right? How far it is make the picture plausible and how it is getting each and every image, how it is getting varied. So these are the different aspects that we are going to discuss in GAN today, right? So here you can see in the down you can see the where this picture is getting placed, right? Next one. So this is known as in painting. We call it as an in painting. So what do you mean by in painting? Here what you will do, some of the images, some portion of the image may be cut, or some of the images may be what we call it is getting grind, or else some part of the image is getting it is getting damaged, right? But the generative adversarial networks have the capability to bring back the image, right? So this is also one of the progressive steps in GAN. Before getting into GAN, we want to discuss some few things about deep learning networks. One of the thing is the another innovation is the use of the recurrent neural networks, right? Means recurrent neural networks in natural language processing tasks, right? Here, recurrent neural networks are able to process sequential data such as text by maintaining an internal state that can remember information from the previous input. As you can see, these are all the step-by-step process where the some of the memory task has to be regained properly to make sure that it will gradually go through the steps, right? So here the generative models, yes, generative adversarial networks and variational autoencoders are also very important innovations in deep learning. These models have been used for a wide range of applications such as image and video synthesis, natural language generation, and data generation for reinforcement learning, right? Another important innovation is the use of transfer learning, right? So this transfer learning, which allows a model that has been trained on one task to be fine-tuned for another different task, right? That is known as transfer learning, right? So in addition to these innovations, right? So in addition to these latest innovations, there has also been a significant increase in the computational power and the availability of large data sets, right? So here you can see for generating these kinds of images, for generating these kinds of networks, or else to generate these kinds of to load these kind of models, it is very computationally intensive, right? So because there to 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 um, to learn or else to train these models, so there will be a need for computational power. There is a need for significant amount of computational power, and the availability of the data sets has to be included, right? Which the, the computationally intensive projects or else the large number of data sets plays a very crucial role in the process of deep learning. Overall, the innovations in the deep learning have led to a wide range of exciting new applications, and we can expect to see even more advancements in the near future, right? And when we are digging deeper into the innovations in the deep learning, it includes the development of convolutional neural networks for image recognition tasks and the use of recurrent neural networks in natural language processing tasks and the generative models such as generative adversarial networks and variational autoencoders for image and video synthesis, natural language generation, and data generation for reinforcement learning. The transfer learning, which we are discussing right now, right, which allows a model that has been trained on one task to be fine-tuned for a different but related task, right? So it is a power of transfer learning and the increase in computational power and availability of large data sets, right? So this is the innovations in the deep learning as of now, right? So here we are going to discuss a little bit brief about the generational adversarial networks and its features, right? So before getting deeper into generational adversarial networks, so generative adversarial networks are generative models that create new data instances that resemble your training data, right? So, for example, you are having one data and you want to transform it to different data. Then you use the generative adversarial network, right? Here, the GAN can create images like photographs of human faces, and even though the faces don't belong to any real person, right? So here, before getting into these generative models, and I just want to discuss few things. First one is the development of convolutional neural networks, right? So before getting into the generative adversarial networks or generative models or a generator or the discriminator, we want to discuss some few things, the basics of deep learning. The first one is convolutional neural networks and recurrent neural networks and transfer learning in detail, little bit detail. Then we'll go into the details of generative model. First of all, we will discuss about the convolutional neural networks. So you already know convolutional neural networks are a type of neural networks that are particularly affecting image recognition tasks, right? So they use a process called the convolution to extract the features from the images, which are then passed through multiple layers to classify or identify the images. So convolution methods have been used in a wide range of applications such as object recognition, image classification, semantic segmentation. Semantic segmentation, when we are dealing with the semantic segmentation plays a very vital role in the image recognition task. Without image segmentation, you can't able to train the data in a very finer way, because many of the image recognition tasks need the semantic segmentation. Right. Next one we are coming next one when we are coming with the recurrent neural networks. So recurrent neural networks is type as I said before, recurrent neural networks is a type of neural network that are able to process sequential data such as text by maintaining an internal state that we can remember information from the previous inputs. Right. This makes the RNN well suited for the natural language processing task. Right. So here the generative models are neural networks. As we are discussing now, this is generative models, right? So these are the generative models. What we order things we see in the is known as the generative models. As I already said, to train the deep learning networks or to train the generative adversarial networks, there is a need for increase in computational power and availability of the data sets. Without this, it is not possible, right? So the availability of the large data sets and the increase in the computational power leads to the pre-processing of the entire input quality, right? So this has been particularly useful in natural language processing tasks such as machine translation, where the model can learn to focus in different parts of the source sentence at different times, right? Another recent innovation is the use of deep learning in the variety of applications, from gameplay into robotics, right? Next one we are going to see is these are the basics of generative model. So when we are dealing with the basics of generative model, here another important innovation, right? Another important innovation when we are dealing with the innovations, here the generative models plays a very vital role, because that is what we are going to discuss in detail now, right? So here, these generative models are a kind of generative model where the generative models can be able to capture the data, right? So to capture the joint probability of x and y and just the of x if there are no labels, right? It includes the distribution of the data itself, right? So as I already said, the GAN or the generative adversarial networks, it's a very innovative architecture. But at the same time, due to the complexity of the architecture, it needs computationally extensive power, right? So next we are going to see the another part or else the another innovation in the deep learning is called the attention mechanism, right? So these attention mechanism allows models to focus on specific parts of the image, right? So you can see in a picture some of the parts where we can able to focus. You can't able to focus on different, but you can't able to focus each and every detail of the image. For example, if you are seeing a person, some of the features of the person will be attractive, right? So that is what we call as an attention mechanism, right? So here the attention mechanism allows models to focus on specific parts of the input rather than processing the entire input equally. This has been particularly useful in natural language processing tasks such as machine translation, where the model can learn to focus on different parts of source sentence at different times. Another recent innovation is the use of deep reinforcement learning in a variety of applications, from the gameplay to the robotics. Next one, as just now, I think in the previous session we discussed about the various innovations in the transformer and transformer based architectures. Vision transformer, Dr. Gupta said about the various vision transformers. Just here, there is another type of transformers called as built-in GPT models, where it is employed in GPT. Right. Another important innovation is use of graph neural networks for the graph structured data. Graphs are you already know graphs are a common representation for many real-world applications such as social networks, molecular structures, and they have been used to solve a wide range of problems such as node classification, link detection, graph classification. Right. So here, again, when we are dealing with the generative models, why it is so hard, right? Because it is as I already said, it's a very difficult task to train, right? So here, when we are dealing with the generative models, the plausible plays a very vital role. So it has to be as good as the real. Otherwise, it is not fruitful enough for this, right? So here, when we are dealing with the hardness, or also when we are dealing with the fuzziness of the generative models, so the main two important things would be there. First one is generator as well as discriminator, right? So here you can see the GAN structure has two parts. First one is generator as well as discriminator, right? So here we are going to discuss in detail about generator, right? So here the generator network is trying to generate a very new data that is similar to the training data. It takes a random noise vector. So here the noise plays a very vital role, because all these images are started and to what we call, and all the images are starting to draw themselves or else to generate themselves via noise, right? Here, whenever the training begins, the generator network is trying to generate new data that is similar to the training data, as I already said. Here, the generator goal is to produce samples that are indistinguishable from the real data, as I already told you. The discriminator network, on the other hand, is trying to distinguish between real and generated data. It takes a sample such as an image as an input and outputs a probability that the sample is real. The discriminator's goal is to correctly identify whether the given sample is real or generated, right? So here I'll just show you the example for that. So here you can see this is the generated data, and here this is the very first step of the generated data. So here it's a fake and this one is a real, right? So how the GAN is getting trained. So for each and everything, so here we can see this is the step. First step is fake and real. Second step also you can't able to generate as close as so that is also looks like fake and it the real one again wins, right? But at the last step you can see it is as close as real. So you can't able to see the difference between the generated one as well as the real one. That is where the real GAN is taking place, right? So here during the process of training, so you can already we discussed the discriminated network. So here you can see the checking. You can see it is a checking process. The discriminated network is trained to distinguish between real and generated data. This plays a very vital role because it has to identify and it has to check whether it is a real and training data, right? So it takes a sample, selects an image as an input, and outputs a probability that sample is real. The discriminated goal is to correctly identify whether the given sample is real or generated. So during this training, the generator and discriminator are trained simultaneously. The generator generates new samples and the discriminator tries to classify them as real or generated. The generator goal is to produce the samples that the discriminator classifies as real, while the discriminator goal is to correctly classify the samples as real as generated. So that is a two distinguishable process for the generator as well as discriminator. Here, the two when we are dealing with the structure of GAN, we can see these two networks are trained in an adversarial manner with the generator trying to produce samples that can fool the discriminator and the discriminator trying to correctly identify the generated samples. And as in the architecture, you can see as the training progresses, the generator becomes better at producing realistic samples and the discriminator becomes better at identifying the generated samples. Eventually, the generator reaches a point where it can generate the samples that are distinguishable from the real data, and the discriminator's ability to distinguish between real and generated data becomes weaker. At this point, the generator can be used to generate new samples that are similar to the training data. GANs have been used in a wide range of applications such as image generation, text generation, audio synthesis, and video prediction that have been also used for tasks such as image-to-image translation, super resolution, and style transfer. The GAN architecture is widely used and has been improved over time to solve various tasks such as WGAN that you already know, the DGGAN, and the big GAN. Now there is a lot happening over there. To be more precise about the generating network, the generator typically consists of multiple layers of convolution, transposed convolution layers, also known as deconvolution layers. That is the reason I just explained about the convolution within networks before slides, right? And here the deconvolution layers are used to increase spatial resolution of the input by learning a set of filters that increase the size of the input. The generator also uses batch normalization and activation functions such as ReLU and leaky. So you already know the activation functions is a very vital role in the training process, and it is used to stabilize the training and improving the performance. The generator network's architecture will be vary depending on the task and the type of data that is generated. For example, if you are using the GAN network for the image generation, the generation network may be using a combination of convolution and the transposed convolution layers, while for text generation, the generator network may use the combination of a recurrent and transposed recurrent layers. So here in this you can see when we are dealing with the structure of GAN, the generator's output here is generated output, right? So this is the generator's output is a generated example, there's an image of text that is similar to the training data. During the training process, the generator is updated based on the feedback it receives from the discriminator network. The generator's goal is to produce samples that can fool the discriminator network, and as a generator and the discriminator are trained together. The generator's ability to produce realistic samples improves as the training goes, right? In summary, a generator is a GAN. In a nutshell, a generator is a GAN is a neural network that generates new data that is similar to the training data. It takes a random noise vector as an input and generates a sample, such as an image that is supposed to look similar to the training data. the generator's goal is to produce samples that are indistinguishable from the real. So this is the basic structure of GAN. Right? So as I already told you, when we are dealing with the type of GAN, there is so many applications of GAN nowadays available. So first one is super resolutions, where you will be having the pixelated. So whenever you are dealing with somebody working in the Photoshop, you already know. So whenever you are having some kind of pixelated images, you want to depixelate it, you want to include the image in the image in the Photoshop, then you increase the resolution, then you increase some of the images which is having a little bit of resolution, but not exactly the same as you want, right? So this is where the GAN or else this is where the deep learning networks takes place. Here, some of the super resolution models are available where it can improve the plausibility of the model. Right? So there are so many websites are available that you can check it out, and in the Google there will be in such places where you can explore different kinds of models. Right? So you can take a look at it how the generative networks and adversarial networks and other kinds of networks is taking shapes. Right? So this is the main aspects I just want to discuss in the aspects of the deep learning. And apart from this, there is so many innovations out there. I think it needs little bit of detail because if it needs some kind of detail as I just explained about some kind of architecture like GAN. So I hope maybe if the time permits for the next time, and if you are dealing models, if you are having the consecutive sessions in the coming days, then we can discuss in detail. Right? Thanks for giving me the opportunity, and I would like to thank the members who are supporting this conference, and special mention for the Davidolo University, and special mention for Dr. Sampathkumar for inviting me into this event. Thank you. And if you are having any doubts in this, please ask me. I will be happy to.
Thank you very much, Dr. Amadavil Jayawal. Thank you very much for your valuable time.
Yeah, I hope there is no questions. In this case, I would like to wind up my speech. Once again, I would like to thank the Davidolo management for inviting me to the session. Thank you. Thank you. Bye-bye.
The participants. Thanks for President Dr. Leta Deswai. Okay, fine. Can I go ahead? Okay, as I was mentioning, thanks to Dr. Leta Deswai, Dr. Uli Johannes, and Dr. Those who are very inspirational. For all the participants will be sent to the registered email. Thank you very much. Hello. think I did not. Okay, fine. Now you are. Thank you very much. So we have come to the end of the session. I would like to extend my heartfelt thanks to Dr. Lata Tesfai, Dr. Muli Agares, and Dr. Mulgetha, who are a great inspiration for us in the university. And, they are putting their efforts to connect the university to the rest of the world. I would also like to extend my thanks to all the participants of Demidola University. Those who were very keen and they were looking forward to this seminar. I hope they would have learned a lot of information about artificial intelligence impact and the technological development. I also like to give a small piece of information for the participants from the other countries. Demidola University is in the western side of Ethiopia. It comes under the Oromia region and it is located in Elam Wolega zone, the fourth generation university, which is striving very hard to connect to the rest of the world in different programs. We have a good team of staff members, and especially we have to appreciate the administrators, those who are very cooperative to conduct such programs. And from our side, we would like to extend our thanks to all the three eminent speakers, those who were really instrumental, those who have accepted our invitations, and they have dedicated their time today. Thank you very much from the entire team of Demidola University. And this seminar was organized under the Department of External Relations Coordinating Officer, Dr. Durba Andesha. Special thanks to you for your effort and you are organizing many more such events. We really appreciate the way the office is going forward in connecting Demidola University with the external universities also. Thank you very much. Once again, I would like to move this to Dr. Sampath. Dr. Sampath, over to you.
Yeah, Dr. Manish, thanks for hosting this entire program, even though a lot of network jitter we are facing in the campus, but the hosting is well. I think the seminar goes well. All the sessions are more informative. Even the session 1 is connected with session 2 and session 2 is connected with session 3. It's a wonderful session. Even in spite of the busy schedule, the speaker has accepted our invitation to conduct the seminar. So I once again heartfelt thanks to the speakers who are handling the sessions, and also the entire team of Demidola University. And I thanks to the computer science department for arranging this seminar. And also I thanks to the Mr. Dirba, who is an external coordinating office director, who helped for all the occasion of the seminar, even arrangement, everything. It's done by the Mr. Dirba. I thank you, Dirba. Last but not least, the participants who are participated in the seminar, they have spent around 4 hours for this seminar. I hope that everything is informative for you. So even the persons who don't know about artificial intelligence, I think you have got some idea about artificial intelligence. The session 1 is about that how that telemedicine in the field of AI, and second is about that how that image processing has taken place in the computer vision, and Dr. Amuda will have taken the part of what is generative adversarial network, because this is the new field in the AI, which have taken part in the how to convert your fake image to the original image, how you are generating the image. So finally, thanks to the Demidola management for giving this wonderful arrangement for everything. Thank you everyone for the wonderful session. So you will receive the certificate. We will send the feedback form to your mail. Once you fill the feedback form, you can receive who has traveled with this seminar with us from the starting onwards. So he would like to say thanks to the presenter who are presenting the seminar. Thank you. I'm handing over the session to Dr. Hanson.
Okay. Drink. Okay, sorry for the disturbance. Then it's my pleasure to thank all keynote speakers and all five participants of the international seminar on impact of.
Sir, feedback link is not sent. Hello, Sampathkumar sir. Hello, Sampathkumar sir. Feedback link is not sent at present.
From the service session, I want to thank Innovation in Deep Learning, which is delivered by Anhadel Research Fellow in Computational Imaging, University of Testu in Estonia. Overall, I want to congratulate the Dadu University and the keynote speaker for and also the organizing committee a successful this grand successful international seminar. They have done a very hard work to gather the international renowned scientists for keynote speakers. I want to say congratulations for the organizing committee for the grand success of this conference. Thank you, all of you. Thank you very much.
Thank you, Dr. Kamu. Thank you very much for your vote of thanks. Thank you very much. Now I would like to have Dr. Mr. Dirba Yandasha to share a few words. Mr. Dirba Yandasha, could you please unmute your mic and share a few words of vote of thanks? Mr. Dirba Yandasha is from the Department of External Coordinating Office. Dirba Yandasha, please unmute your mic. Am I audible? Dirba Yandasha, please unmute your mic. No, we are not. Please, you're not audible. You're not audible. Could you please? think I'm audible. Dirbandasha, could you please unmute? You have muted your microphone. Could you please unmute?
Mr. Dirba, you can unmute now.
Yes, yes.
Yeah.
Yeah, very good. Go ahead.
All right. On behalf of Damdolo University and the External Relations Coordinating Office, I would like to say thank you for all participants for today's international seminar. And as you know, Damdolo University is a fourth generation university in Ethiopia, and now we are hosting different conferences, different seminars that give towards improving quality of education at all. So we, as International Relation Coordinator Office, we like to say thank you for your efforts, all participants on today's seminar. So in the future, we will coordinate and prepare such seminars, and we need the joint work of all Indian expatriates in the other hosting countries. So I would like to say thank you for your nice effort today.
Thank you, Mr. Dirbandasha. Thank you very much. Once again, we extend our heartfelt thanks from Damdolo University to all the participants, all the leading speakers. Let us hope to see you all soon in another very big event. And anyone who's interested to have a research or any other short programs related to this topic, you can contact Dr. Sampathkumar from the Department of Computer Science. Thank you very much once again to everyone. Have a good day. May God bless you. Thank you very much.
Thank you. Thank you.